Sometimes capitalization matters.
Okay. But spaces not.
Spaces, any space is equivalent to any other space.
Okay.
I'm trying to think if there are any exceptions to that. There may be some exceptions to that I'm not thinking of. But for the most part, if you have, at line 11, you have extra line breaks, or you have just a bunch of spaces out in the middle of nowhere. Java compiler doesn't care one way or the other. Java is case sensitive, so things that are specifically part of Java will not work if you don't have the capitalization right. If you type a name, for instance, line 12, N1 and N2 are names that you're defining. If you try to use them somewhere else and use capital N's, that wouldn't work. Java would complain horribly. Java is very I forget what the actual word is, but you can't just start using a name and expect Java to figure it out. You have to specifically tell Java, I am going to use this name. And that's in essence what line 12 is doing. We'll talk about that in more detail in the next chapter. The author makes note of classes and methods at this point, mentions them very briefly. In general, classes are groups of code, and everything in Java is a class. You can't have code that exists outside the class. Every Java program exists in one or more classes. And a method is simply a grouping of code that's relatively self-contained that can be invoked, run at one time. When it's invoked, all of it runs. And you can have multiple methods in the same program, multiple methods in the same class. And we'll talk more in detail about methods and classes in Chapter 5. But for now, we need to know enough that classes and methods exist so we can talk about object-oriented programming in the next section. Which is where we jump to now. So, section 1.3, Programming Basics. Java is very much a subscriber to the object-oriented programming idea, philosophy. This is the notion that we deal with our world in terms of things. That is a fire alarm. It's a thing. It has certain characteristics. It's red. It has a light on it that blinds you. It has a speaker. And it can do things, or things can be done to it. It can, start alarming. A door is probably a better example. It can open. It can close. It can have a state. It can be open or closed. It can be somewhere in between. It can be ajar. And it has a handle, a window, all sorts of other stuff. Basically, objects in real life have attributes and operations that can be done to them and that they can do. And in programming languages, both of them are considered operations that can be done on them. And in real life, we can have a description of something. A chair has 4 legs, a seat. It can break. It can be sat in. A whole bunch of other stuff. And we have a physical chair. You are all sitting in physical chairs. They are instances of the idea of a chair. In Java, we have the same thing. We have, in all object-oriented languages, specifically in Java, we have classes, which are the idea of a chair or a door or a fire alarm. We'll talk specifically about them much later on, Chapter 5-ish. Instances of these things, we're already using instances of these things. We're using scanner, we're using system and out. they are things. They are representations of real-world concepts. Input and output are real-world concepts that are embodied into a class. A scanner, while it's kind of an arbitrary name, also has it's the encapsulation of some notion in code. The ability to retrieve things from something that's kind of ambiguous. We also have methods. These are the operations. And programming would be very boring if it didn't actually do anything. Is anyone familiar with HTML? Lots of people consider that to be the first programming language they have ever learned. I hate to tell you, but it's not a programming language. It's a language, but it doesn't do anything. It's more the description side, and doesn't really have any doing power. No methods. Java has methods. It can do stuff. And methods are kind of a microcosm of programs. They have inputs, outputs, and do something. The inputs are the things between parentheses, and when we're using them, we call them arguments. So this hello out there is an argument to system.out.println. And they can have output. Nothing here has output. We're talking about two types of output. One is screen output. One is black box output, we'll call it. The opposite of input. We put something into a method and something comes out. We don't have anything that comes out of a method. Later on, we'll find out that that's a lie. But for now, that's the truth. And all of these methods do something. We don't know exactly what they do. We trust them to do what they say they do. Println, we trust that to do something that it sounds like it does. Next int, we trust that that gets the next integer from this keyboard.
So the methods are before
The method names are before the parentheses, yes.
and what's in the parentheses
Is the argument.
So like system out is the object, print ln is the method, and then the argument is within parentheses?
Correct. So that's how object-oriented programming works. There are several programming languages that do this, some more so than others. Some are very much more object-oriented than Java, which is kind of surprising because Java is very, very object-oriented. And some that kind of use object-oriented, like, hey, we can do that too. It's not our primary goal, but we can do that too. C++, for instance. Objective-C is kind of somewhere in between. It kind of hasn't figured out where it wants to be. Objective-C is very object-oriented, but because it's based on C, you can also do some non-object-oriented stuff with it. And going more theoretical with object-oriented programming gives rise to three pillars of object-oriented programming: encapsulation, polymorphism, and inheritance. We'll talk in more detail.
What do you mean by pillars?
Pillar.
What do you mean pillars?
Pillars.
Oh, pillars.
Important points. Encapsulation, polymorphism, and inheritance. Encapsulation is this black box concept. If you have trust issues, you might have issues with Java. The whole idea behind encapsulation is this object does what it says it does, and I trust it to do what it says it does. It is not my concern whether or not it does what it says it does. It's also separation of concerns. I do what I'm supposed to do. I do what I'm supposed to do well. I make sure that I do what I'm supposed to do no matter what happens. Other objects, it's their responsibility to make sure they do what they're supposed to do. Same thing with methods. Polymorphism is kind of difficult to talk about without having a physical representation of it. We'll have the actual implementation in Java a little bit later, but polymorphism is the idea that we can have something, two different things with the same name, and the right one gets picked when it's needed. And the inheritance is the idea that there's a relationship between, is a relationship between objects. So a cat is an animal, a dog is also an animal, a boat is not an animal. And we'll get into more about that when we talk about objects and especially inheritance. But there's a nice diagram on page 25 about inheritance hierarchies. And these are used extensively in the Java framework. You don't need to understand this in its entirety in order to use the stuff in the Java framework, but understanding this makes it all make sense. When you're writing code, you will run into errors. That's not a you may run into errors. You will run into errors. It doesn't matter if you're code ninja. You will run into errors. You will find bugs. You will occasionally forget something that's important. And occasionally when you're teaching, you'll forget to talk about something that's important. The semicolon at the end of the line is very important. If you miss the semicolon, Java will complain about it. At the end of every, we'll call it an instruction. At the end of every statement is what it's really called. You need a semicolon. You don't need a semicolon at the end of a block, but at the end of a method call, at the end of an assignment, at the end of a variable declaration, lines 12, 15, 16, 17, 20, 21, 8, 9, 10, and 1. All need semicolons at the end of them. There's no, you can put a semicolon here if you want to. They need a semicolon. One of the easiest mistakes to make and hardest mistakes to find is the missing semicolon at the end of the line. Because Java will invariably tell you that the error is on the next line. If you look at the line that Java is complaining about and it looks perfectly fine to you, look at the line above and make sure you have a semicolon. Make sure a semicolon is supposed to be there. So there are 3 types of errors that you can encounter. The first type is a compiler error, which is you try to compile something in Dr. Java and the bottom half of the window says something with an angry yellow background. So we'll try compiling this. Angry yellow background. And here it actually got it right. It said, I'm missing a semicolon. That's the first kind. That's a compiler error. The second kind is a runtime error. This is your program compiles perfectly fine, but when you try to run it, it explodes. And then you get angry red text. Let's see if I can get angry red text to happen. This should be fun. Don't do this. Ever. I thought I just did. Compile. Sure. That's... I'm using syntax that you don't know yet, but don't worry about that. I'm just trying to get the error to come up. There we go. Angry red text. This is a runtime error. Usually takes the form of what's called an exception, which we'll talk about later. Basically, this is, I saw something that I don't understand, I don't know what to do, please help. And we'll learn there are ways to help Java out here. But for now, when we do something that Java really doesn't understand, it explodes on us. This is a runtime error. The program compiles fine, but when you try to run it, it does not run fine.
So this is when you on the assignments, when you said it's the 40 points, if you get a red error.
Yes. So yellow error, 25 points, no questions asked. Red error, 40 points, no questions asked. The final type of error is let's put this back. The final type of error is what's called the logic error. This is it compiles fine, it runs fine, but it doesn't do what you expect it to do. This is usually what's referred to when we talk about bugs. Most software that gets released doesn't have, except in extreme cases, doesn't have certainly compile time errors, because usually it's already compiled when we get it. Usually doesn't have runtime errors, it usually runs fine, but sometimes it doesn't do exactly what it's supposed to. And when we talk about selection and conditions, the most common type of logic error is we join conditions together incorrectly. So we want something to happen if condition A and condition B is met, and we accidentally tell Java if condition A or condition B. That's both the most common and the easiest to fix, fortunately. Sometimes the hardest to find. But those are the three types of errors. And the book has a nice way of putting this. Syntax errors, compile time errors, are grammatical mistakes. Missing a semicolon, same as in English. Runtime errors occur during execution, and logic errors are conceptual mistakes in the program or algorithm. So we tell the computer something to do, the computer understands exactly what we want it to do, and the computer runs exactly what we tell it to do faithfully. The only problem is what we told it to do and what we want it to do are two completely different things. And the book talks a little bit about the API documentation as well. We're not going to worry about the graphics supplement chapters in the book. If you're interested in, let's see, they do applets. So if you're interested in putting Java on your website, it might be worthwhile to look at those sections, but we're not going to talk about them in class. None of the assignments have anything to do with them, and they certainly won't be on the exam. So, speaking of assignments, questions on anything that I talked about so far? Cool.
Is there an error message with the logic error, or just one?
No.
Just won't work as it's
just won't work. It's the error message is, well, that's not right. Yeah. Okay, so because of I usually don't assign homework on the first day of class, but because of the summer semester, it's kind of hard not to. So there is homework. Assign today, due a week from today. And it's a fairly straightforward assignment. Objectives, to get Dr. Java up and running. Most of you have already done that here, so you can check that one off. Write, compile, and run a very simple Java program. It's basically an extension of the code listing on page 15. A little bit of extra math, and that's it. Test the programming assignment submission system. That's the one that's probably going to be the most difficult. So the actual assignment involves putting this code listing into Dr. Java. These little can't highlight them. These little, geez, I'm not even gonna bother. The little things that look like no character you've ever seen. Yeah, I guess they look kind of like them. Those are spaces. Sideways brackets. Yes, the sideways brackets are spaces.
Any assignment with the capitalized the CS before the
This part.
Yeah, we have that and the actual
So anything in double quotes is not actually Java code. It is what's called a string. It's something that, in theory, humans are going through. So capitalization is really up to you. I didn't mention comments. Comments are bits of text that the compiler just completely ignores. And they are surrounded by the slash splat, or slash asterisk, and asterisk slash. So they start with these two characters, end with these two characters. For now. I think Chapter 2 talks about other types of comments. But for now, use that comment block and modify it to have the right information. It will show up in green, yes. Save the file as helloworld.java. Dr. Java will automatically do that for you since the name of the class is Hello World. Compile and run the program. And I want you to add add onto this program by asking for two numbers and printing the sum, difference, and product. Add, subtraction, and multiply. Someone over here experienced an issue with subtraction. And you'll actually run into it with addition as well. If you try to use a plus sign between a string, something in double quotes, and a number, or something that represents a number, it will turn that whole thing into a string. So you can use parentheses to do the calculation first, and then basically add it to the string. Or you can print them on separate lines. The listing on page 15 doesn't actually use the plus sign with strings. Chapter 2 does. So either way, there is some flexibility here. As for submitting it, I want you to zip up the helloworld.java file, name the zip file as I mentioned at the beginning of class, and email it to me. Oh, that's cool, that's a link, with the proper subject. As for how to zip up a file, I'll show you on OS X. It's very similar on Windows. If it's just one file, you could click on the file, right-click it. On OS X, it's compress firstprogram.java. On Windows, it's send to, and then that pops out a little menu, and then it's compress zip folders. These machines have a copy of WinRAR on them, so that you have a lot of extra choices. It's like compress this, compress an email, compress using some other archiving method. Don't worry about all that. Just do send to and then compress zip folder. It has the icon is a little folder with a zipper on it. Not a stack of books. Folder with zipper, not stack of books. In future programs, when we have to send multiple Java files, the procedure is exactly the same. We just select multiple files, right-click, and then on OS X, it's compress two items. On Windows, it's exactly the same. There's no change. Send to compress zip folder. Both operating systems just pick a name. So change the name. On Windows, you can hit F2, and that will bring you into rename mode. On OS X, it's enter.
and CS 1150.1206 dash, for me it would be Parks dash Brian dash PA1. It's a mouthful.
But that ensures that it will get collected to the right place and you'll get a grade for it.
Questions on that? Yes, Jill.
I have 3 different programs for the first one. So that's what you use it, right? I have a class file or a file and a file. Can I still have 3 different programs?
So, right, you do end up with 3 different files. And
this might not be a bad time to talk about. The .java file is the one that you actually write in Dr. Java. That's the source file. That's what I want zipped up and sent to me.
The .java file?
The .java file. The one that is .java squiggle is a backup file.
I have a .class file, but I don't have just a .java file. Is it a .java file?
Aha. So on these machines, did I mention how much I love Windows? Windows doesn't show you the extension by default, the part after the dot, if it knows what the file is. On these machines, there are at least 2 different programs that already claim to know how to open Java files. So Windows thinks it already knows what a Java file is. So on your machine, it might show up as a JGrasp Java file. That's the Java file. It actually does have an extension of .java, you just can't see it. There is a way you can turn that on, but you can see that it's a Java file. Yes? Ooh. Right, so if the, it's been a while since I've used so much. So on this page, there is an option for the OS X app, the Windows app, and the jar file. If you download the jar file, I think in Linux, finally, you can actually double-click that and it'll do the right thing. Ubuntu might actually have a package. It doesn't have a Dr. Java package. On one of these, so there's actually an Eclipse plugin for Dr. Java. I don't know why that makes sense or how that makes sense, but I've never tried it. But I'm pretty sure, I know if you download the jar file and you start the jar file, it should do the right thing. I think you can double-click jar files in Ubuntu now. If not, I can construct a command line that will allow you to type Dr. Java and have it do the right thing. Right. Any questions on that? How to submit the assignment? So in the remaining, what do we have? 45 minutes? You're welcome to work on this assignment. In fact, I recommend doing it. That way we can work out the kinks in the assignment submission system, in understanding how Java works, getting Dr. Java up and running, that sort of thing. Mm-hmm. Home run.